All right, so in this video we're going to take a look at section 4.2 and we're going to look at building linear functions from data. So the first objective in this section will be to draw and interpret what we call scatter diagrams. All right, all a scatter diagram really is we're going to plot the points given from a data set. So in this first example it says the data listed represents the apparent temperature versus the relative humidity in a room whose actual temperature is 72 degrees Fahrenheit. So we're plotting the humidity as the independent variable and the apparent temperature as the y variable. Right? So, most of us live in Florida here, and we all know that when it's really humid outside, it feels much hotter than the air temperature. So we're plotting the apparent temperature, right, what it feels like to us based on relationship to the humidity in the air. So if we were to look at these points in particular, let's say we wanted to plot them by hand and create what we call a scatter plot. Part B is going to ask us to use a graphing utility to draw the scatter diagram, and we'll do that in just a second. And the letter C just says, describe what happens to the apparent temperature's relative humidity increases. So we'll look at the graph and make that interpretation. So real quick, I have a screenshot. So let's say we had gridded graph paper, and by hand we were plotting the relative humidity in the bottom as our x variable, our independent variable, and we were plotting the apparent temperature, right, what it feels like as a function of the humidity. So if we were to take an XY grid and we were to by hand plot on the prior slide, or plot these data points over here on the left, we would see this basic type of graph. And then down here on the bottom right is a screenshot of what it might look like on a TI graphing calculator. And I'm going to show you guys how to do that in just a second. I'm going to also show you how to use Desmos graphing tool to do that as well. Now, just to kind of finish off the question here, based on this graph, right, letter C said, describe what happens to the apparent temperature as humidity increases. So we can pretty easily see down here that as humidity is increasing, apparent temperature is also increasing. So a nice visual interpretation here, right? For most of us in the world that are visual learners, all the things we're going to do in this class, we want to make very visual because it's a lot easier to see visually when things are increasing or decreasing. We can really see behaviors in a nice way from graphs, from a visual interpretation. All right, so let's take a few minutes and let's talk about how we would do this on graphing technology. So let's say I wanted to do the scatter plot on my TI calculator. Here's the process that I would go through. So with my calculator on, I'm going to hit the stat key. And the very first option, I have an edit list, a calc list, and a test list. Under the edit list, I'm going to choose the edit option. So I'm just going to hit enter right here. And it's going to bring me to some lists. All right, so you should see a menu very similar to this. And up at the top I have list 1, and then I have list 2 over here, list 3, so on and so forth. And all my lists are blank. Right, now if your list has stuff in it, what you can do is you can hit the clear button and press down, and it will clear out the entire list for you. All right, so if you have some numbers in there, just go up to the name of the list, hit clear, push down, and it'll clear the list for you. So what I'm going to do then is in list 1, I'm going to type all my x values, and list 2, I'm going to type all my y values. So the calculator likes to do this as a column. So I have 0, 10, and 20, so I'm going to type 0, enter, 10, enter, 20, enter. I'm going to continue through this process. I'm going to pause the video here so I can just do this without you having to watch all of it. Okay, so I've entered all of the x values in list 1. I've entered all of the y values in list 2. And the only thing I would caution you on when you're doing this by hand, really easy to just punch a wrong number and have data entry errors. All right, so I just want to make sure I kind of go back and double check 0 pairs with 64, 10 pairs with 65, 20 pairs with 67, so on and so forth. And just do a little quality check, make sure I've entered all my data correctly. All right, now that I have all my data correctly, I'm going to do the scatter plot. So here's how I'm going to do that. If you notice above the y equals key on your calculator, it says stat plot. So I'm going to hit seconds and y equals, and I'm going to come to the stat plot menu. Notice stat plot 1's turned off, stat plot 2's turned off, stat plot 3's turned off, so on and so forth. So I'm going to go ahead and hit enter on stat plot 1, and I'm going to go in and change the details. So the first thing I'm going to do is hit enter to turn the plot on, and then I can choose the type of plot I want next. Now I'm going to leave it on the first option because the first option is just plot the points. That's a scatter plot. The second option would be connect the dots. The third option would be a frequency histogram. We're not going to do any of that stuff in this course. We're going to leave it on the first one. And then I can tell it what is the X list. Okay, so this is automatically set to L1 and L2, but if I had to change this just to show you, above number 1 key is L1. So I could do second number 1, hit enter and change that if I had to. Second number 2, hit enter and change that if I had to. And then I can change what the point looks like. All right, now if I just hit the graph button, obviously I'm in a minus 10 to 10 on my x-axis and minus 10 to 10 on my y-axis, and that is not going to see these points here. So probably the easiest thing to do to adjust the window is to hit zoom and choose the zoom stat feature. So what it's going to do, it's going to look at that first stat plot and it's going to adjust the x-min x-max and y-min y-max to fit the data points into the window. And there's my data points that we saw on that slide. All right. And then just to show ourselves what the calculator did, if I hit the window key, it made the x-min -10, the x-max 110. So it went 10 before this x and 10 after this x. And then a y-min and y-max, it adjusted appropriately, and it gives me that graph there. And again, if I jump to the next PowerPoint, we can see that those two graphs match. Now, let's suppose we wanted to do this on our web-based calculator, Desmos.com. How would we handle that? All right, so I'm going to bring up Desmos either on my computer or the app on my phone that's completely free, and I'm going to want to plot the data points here as well. So the easiest way to do that is up here in the plus button. I'm going to add a table. I'm going to literally do what we did on the calculator. I'm going to add the x and y coordinates here. So I can type, let's see, 0 was the first one, hit enter, 10, hit enter, 20, and look, Desmos is guessing what pattern I have going on here. So this is pretty nice. I can go all the way up to 100. Right? Now the only problem is it's not going to be able to guess the pattern on the y's, so I'm going to have to type those in manually. Again, I'm going to pause the video so you don't have to watch me do that. Give me just one sec. Alright, so you can see here I've completed my table in Desmos. And the table is actually graphing. I just can't see it in the window over here because I haven't adjusted the window appropriately. So let me go ahead, and one thing I like about the app is that I can pinch with my fingers and zoom in and out really easily. And on my computer, I can use the scroll button on my mouse to zoom in and zoom out really easily, right? And I can click and drag and move the screen around, right? Another way to do this is I can go up, here's my zoom in and zoom out keys, right? Or I can go up to the graph settings and I can change the x-axis. So we had what, -10 up to 110 on the calculator. So let's kind of mimic that same idea, right? And then my lowest y value was 64. So let me start at 60. And my largest y value down here was what? Was 75. So let me go here and change that to 75. I don't know why that didn't accept 60. There we go. So if I hit enter, and then I can click and close this window. And I can just kind of drag and drop as we go here as well. There's those points. And I think I have a typo. I do have a typo. This looks different than my calculator graph, and it's because that last point should be 76. So let me type 76 there. Right? And then I can even click to hide this list if I want. Right? You can see my scatter plot there. Just to show you a couple cool things, if I open the scatter plot back up, I can click and hold, and I can change the style. So I could have it connect the dots if I want. I could have it disappear the dots if I want. I want the dots there. And I can even change the color to be blue or green or purple or red. All right. So if I was going to do a stat plot on the TI or Desmos, either one of these would produce a scatter plot, a plot of all the data points. Okay, so the next objective in the section would be to just discuss the idea, but just distinguishing, excuse me, I can't speak this morning, distinguishing between linear and nonlinear relationships. This is a really simple idea. If we look about just kind of some examples of scatter plots in general, Right, here's two generic scatter plots where it looks like on this first scatter plot the data would fall along a line, right? And the second scatter plot, the data would fall along a line as well. And the thing to keep in mind here, in the prior section, we talked about all the points had to lie exactly on the line for us to call the data linear. And if the slopes were different between any two pairs of points, we said the data wasn't linear. And what we're doing in this section is we're abstracting to something that's a little bit more realistic. So much more realistic to realize that not all the data will lie exactly on the line in a real-world situation. So what we're going to tend to see in this section is data that seems to cluster along the line. And here's what those scatter plots might look like. And then we could have scatter plots that aren't linear. So here's data points that don't seem to lie all along a line here, right? And here's data that doesn't seem to lie along a line. This seems kind of like a cubic function, maybe, if you've heard of that before. And this seems kind of like a parabola, right? But anyway, these are nonlinear in the sense that the points don't seem to cluster around the line. And then one other example of a nonlinear data set. So in this section, we're really talking about some realistic data. And if data is realistic, it's going to cluster around a line, but it's not necessarily going to fit all exactly on the line. And then we might want to talk about whether data is non-linear as well. Okay, so let's kind of come back to that example that we started this section with. And let's take this a little bit further. So let's suppose that we had a problem where we're wanting to take 2 points and find an equation of the line containing those 2 specific points. And then letter B, what we're going to do is graph the line on the scatter diagram. So let's say we grab the first, select 2 points, 10, 65, and 70, 73. Now, if I go back to the prior slide, there were no instructions on which 2 points to grab. So I chose to grab x equals 10 and x equals 70. And I'm going to find the slope of the line and the equation of the line through those 2 points. So again, remember the first thing we always have to do is find the slope. So I'm going to do change in y, 73 minus 65 in the numerator, divide by change in x, 70 minus 10 in the denominator. And that's going to give me 2/15 as my slope when I simplify that. Then I'm going to use my point slope formula. So I'm going to plug my slope of 2/15 in, and then I'm going to pick the point 1065. So I plug in the y of 65, the x of 10, and if I solve for y, I get the equation of the line to be 2/15 x plus 191 over 3, right? So my slope is 2/15, and my y-intercept is 191 over 3. Now, if I had a graph, that was pencil paper graph, right? Here's the 2 points in particular. So here's the point where x equals 10. I used that to find my equation, so the line has to pass through it. And then I picked the point where x equals 70. So again, my line has to pass through those 2 points. I found the equation through those 2 points. And then we can see the other points kind of lie generally along that line. Now let's suppose we wanted to use graphing technology, right? So we wanted to use our TI or we wanted to use Desmos to find a line that fits the data. And what we do is we call this finding the line of best fit. Now, I don't want to get too deep on this, but when we talk about finding a line of best fit, what we're talking about really is finding a line where all the points are as close as possible to the line. Now, if you really want to learn how to do this, you can Google search what's called linear regression, or you can just look up regression in general. And if you Google search the term regression, what you're going to find basically is a conversation that would go into a statistics course. And what we're going to do is we're going to try to minimize the error or the distance that each point lies from the line. That's not an easy task. And that's why in this course we're going to lean on technology to do that for us. All right. So what you're going to generally notice is the line will lie pretty much smack through the middle of the points. So if the line is falling in the middle of the points here, the points that are kind of on the line have a small distance from the line, small error, and the points that are below and above the line kind of average out their distance from the line to be relatively zero as well. So anyway, I don't want to get too deep on this, but the idea of a line of best fit is not what we saw in the example that we had right here. Right? In this example, we specifically picked 2 points. That's not what we're going to do when we do a line of best fit. A line of best fit, which again sometimes is called a linear regression, we're going to allow technology to find the line that best fits all of the data points collectively. All right, so how would we do that? So let's see, if we had graphing technology here, let me turn my calculator on. If I already plugged in all of my points into my graphing calculator here, right? So what I'm going to do is go to the home screen. I'm going to do second mode and quit to the home screen. And from the home screen, I'm going to go back to stat key, and I'm going to arrow over to the calc menu. And you're going to notice the 4th option is linear regression, right? So this is my line of best fit. So I'm going to call that out to the home screen. Now, I have an older version of the calculator here. If you have a newer version of the calculator, it's going to bring you to a menu. And the menu is going to ask you, what's the X list and what's the Y list. Now, my old calculator doesn't ask me for that. So what I have to do is I have to tell it the X list is second number 1. Okay, here's L1. And then I would put a comma, and I would say the Y list is second 2, right? It's L2. So again, the newer calculator is going to have a menu. It's going to prompt you for those things. The older calculator doesn't. When I hit enter, it's going to give me the line of best fit. So here's the line that best fits the data. Now I could scribble this down on paper. I could write this, here's the slope is being called the letter A. So my slope is 0.120909009, right? The y-intercept B is 64.4090909 as well. So if I were to round, let's say I did 3 decimal places, I'd have 0.121x and 64.409 if I went to 3 decimal places. So I got 0.121 and 64.409. So I could go 0.121x plus 64. What was it? 09. I forget what it was. Hang on a second. Let me go back to the home screen. 64.409. All right, 64.409. So I could just scribble down to, let's say, 3 decimal places, and I could hit graph, and I can see there's the line that best fits the data. All right, and I just want to point out to you that it's kind of hard to tell from the graphing calculator, but this line does not have to pass through any of the points. So just like on our example in the PowerPoint, we had the line passing through 2 points specifically, but this line of best fit, none of the points have to necessarily lie on this line. The whole idea, again, about a line of best fit is that all the points are as close to the line as possible. Right? Again, if you want to really learn about this, please feel free to Google search linear regression or take a statistics class with me next semester. We'll talk about it in depth. Now, let's suppose we want to do this in Desmos. How would we do this in Desmos? All right, so if we're going to add a linear regression or a line of best fit to Desmos, so what we're going to do, once I have my data point here, what we're going to do down here, I'm going to click down here to add an expression, and I'm going to type y1. So I'm going to say the y variables are going to be linear. So the way that I have to tell Desmos that I want a line of best fit is in the following fashion. So again, I'd say y1, and then I'm going to click the ABC button, and I'm going to use the tilde key. I'm going to say y1 is approximated by the slope, so I'm going to type m, and then I'm going to say x1. So let me go back to my variables. I'm going to do x1, and then plus b. So I'm going to say plus, and let me do letter B here, right? So I'm telling it, the Desmos here, that I want a line of best fit, and I want x1 and y1 to be related to each other, okay? I want to point out to you what it does is it plots the line of best fit here for me, and it tells me what M and B values are. And notice this is the same thing I got in my calculator, right? I got an M of 0.121 when we rounded, and 64.409 when we rounded to 3 decimal places. So there's my line of best fit, and it even throws the equation of the line onto the graph for me, and I can see how that line fits that data set there. Something else that's kind of cool here, notice it's giving me what's called the correlation coefficient. Right? So if you look at the examples in the textbook, they talk to you about the correlation coefficient, and there is, I think, a homework problem where they ask you for this value as well. Now, all this is really telling me is how good the data fits the line. So in a statistics course, the correlation coefficient, the closer that it is to 1, the better the fit is. So a correlation coefficient of 0.988 is amazing. That's really awesome. That tells me that the line fits this data really, really well. If my correlation coefficient was like close to -1, like say it was -0.9, that would just tell me that the line is decreasing and has a negative slope. And it's still a really good fit. If the closer to 0 that this correlation coefficient gets, the worse the fit is. So like let's say R squared was like 0.4, that's not a very good fit. And what that probably would tell me is that the data is not really linear. You might want to use a different model instead of a line to fit that data. Something else that's really cool about decimals, I'll show you this, and then we'll finish up the lecture here. If I plot the residuals, right, this is what I was telling you about is the values of the errors, right? So this is how far each point is away from the line. So this, we call them residuals, or they're the errors of the estimation. In fact, if I zoom out, it plots it on the grid for me. Where's it at? Here's the residuals. So these are the errors being plotted for each of the points. It just shows you the distance each point is from the line. All right, anyway, so if we were going to do a line of best fit on the TI, we talked about that. And if we were going to do a line of best fit on Desmos, we've talked about that as well. All right, now one last thing I do want to show you is Desmos showed us the correlation coefficient, R squared, but the calculator didn't show me that. So the very first time I do a linear regression or a line of best fit on my calculator, I have to tell it I want to see the correlation coefficient. So if you have a homework question that's asking you for that information, here's how you're going to turn that on. So what I'm going to do second number 0. And if I do second 0, it takes me to the catalog. And I'm going to do what's called turning on the diagnostics. So you'll notice in the upper right-hand corner, it's on the alpha lock. So I'm going to punch the letter D. Where's the letter D? Let's see. Here's A, here's B, here's C, here's the letter D. So I'm going to jump to the letter D by hitting this button. And then I'm going to scroll down to diagnostics on. So I'm going to choose diagnostics on. I'm going to bring that back to my home screen. I'm going to hit enter, and it's going to say done. So now if I redo my linear regression, and so if I go back to stat, I go over to calc, and I redo my linear regression here, you're going to see now it gives me the same equation, but now it displays the correlation coefficient for me, R squared. So here's a screenshot of that, what that would look like. All right, so we found the line of best fit. We could plot that line on the calculator. We did that already. And then letter C says, let's interpret the slope. So if we look at the slope here, right, the slope is 0.121, right? Think about what that means, right? What that says is like for every 1 degree increase in relative, 1% increase in relative humidity, the apparent temperature increases 0.121 degrees, right? So we're increasing, our slope is positive. So for every 1 unit change in x in our denominator, we have a 0.121 unit change of y in the numerator. So that's the apparent temperature increase of 0.121 degrees. All right, and then letter D said use the line of best fit to predict the apparent temperature of a room whose actual temperature is 72 degrees and relative humidity is 45%. All right, so the way I'm going to do this on my calculator, notice that what they're giving me here is like the X value of 45% humidity. So if I bring up my calculator, I have an X value of 45%. So if I go back to my graph, I'm going to just trace, and I'm going to punch X equals 45. Oh, before I do that, notice that up here in the left-hand corner, it's tracing the ordered pairs. I don't want to trace the ordered pairs. Right? If I hit the right arrow, it's jumping along the points in the data set. I want to trace the line. So I'm going to hit the down arrow, and you're going to see now it's tracing the line. So now if I hit the right arrow, I'm tracing along the line. All right, so I'm going to hit 45 here for my percentage, type enter, and it's predicting the apparent temperature to be 69.854 degrees Fahrenheit. Right, and on Desmos, remember what we can do is we can just click and hold our left mouse and drag a point, and we can trace. And so I'll just trace to 45, and there's that same temperature of 69.85 rounded. Okay, that's everything we wanted to talk about in section 4.2. Again, if you have any questions, please post on the discussion board. I will see you guys in the next video.